Hello, my name is Cody Nichols, and this is Introduction to Hazardous Materials Response Teams. And this is a companion piece to my capstone paper, which is all about firefighting in rescue situations involving toxic environments, such as hazardous materials, and the need for the department I work for to have clear protocols to allow firefighters to make rescues in those conditions. So to start off with, this presentation is mostly introductory information because in the paper there's a lot of heavy material that's pretty unfamiliar and new to the reader if you're not in a hazardous materials team or a firefighting organization. So I figured this would be a good opportunity to present some of those terms and concepts that I go through pretty in depth in the paper. So this is the hazmat team I'm on. It's part of the Tualatin Valley Fire and Rescue, or TVFNR, hazmat team number 9, and we're in the Beaverton, Oregon area. So the State of Oregon Fire Marshal's Office has authorized the formation of 13 regional teams that respond to hazardous materials incidents in the designated area of the state. Tualatin Valley Fire and Rescue, TVFNR, hazmat team is made up of 30 full-time firefighter EMTs or firefighter paramedics, of which 7 are on duty at any given day. You can see from this fuzzy map here, this is the Portland area, right here. And our team covers this whole area all the way to the coast, back to the I-5 corridor up into Portland. So we cover all the towns south and west out to the coast. It can take us up to 2 hours to get out to these towns here on the coast. So what are hazardous materials, or hazmat? So the Department of Transportation, DOT, describes it as any item or chemical which, when being transported or moved in commerce, is a risk to public safety or the environment and is regulated as such. Down here, it's what's known as a 704, and it's a building placard. You find this on the side of any building that houses hazardous materials, such as a swimming pool, the area where they store the chlorine. You'd find this on the door. And over here, each one of these diamonds is a placard that you'd find on the side of a semi-trailer or a rail car or a ship that carries hazardous materials. Each one just designates and lets people know what's inside. Sometimes you can have more than one on a trailer too, depending on the chemical. So 2012, 2.5 million tons of hazardous materials were shipped, either through the roads, rails, waterways, pipelines, or by air. The average shipment travels 114 miles. So 114 miles gives ample opportunity for accidents to happen, such as a plane wreck, or people digging and they hit a pipeline, or a rail car spill, will go off the tracks, as was the case last year near Moisure, Oregon, where a bunch of Bakken crude oil spilled everywhere. So different types of hazmat emergencies. Up top here is an example of a bromine leak from a rail car. This was in Russia. Sent 55 people to the hospital. Down here was a leak in Festus, Missouri, and this was a chlorine leak. You can see this cloud of chlorine gas hugs the ground. And that sent 22 people to the hospital. And up here is just kind of a not too uncommon situation where somebody will stumble upon a bunch of these 55-gallon drums and they're not labeled and nobody knows what's inside of them. It's a illegal dumping site. And the hazmat team is called in to figure out what's inside of these products so we know how to dispose of them safely. So in the paper I talk about the acronym CBORNE: chemical, biological, radiological, nuclear, and explosives. So chemical is like chlorine, bromine, things we talked about, anything that maybe industry would use to manufacture goods. Biological would be things like Ebola or smallpox. Radiological is like anything that would spread radioactive material, such as a dirty bomb. The nuclear would be a nuclear device. And explosives are things like TNT. And we don't really deal with explosives. We are trained to recognize them though. So hazardous materials incidents can happen accidentally, such as a rail car that overturns and leaks out its contents, or it can happen on purpose, such as terrorism. And this top picture here is photos after the 1995 Japanese subway attack, where these members of this extremist religious group released sarin gas from the subway, ended up killing 13 people and injuring 55 others. Down below this white powder envelope is an example of the anthrax incidents that happened shortly after 9/11, and it killed 5 people and sickened 17 others. So these type of terrorist acts, while frequently uncommon, are still very real, especially with the rise of ISIS in Syria and the sarin gas and the uncontrolled chemical weapon stockpiles over there. It's not unthinkable that something like this could happen here, and first responders to these incidents are almost always going to be fire department and paramedic people. So it's very important that fire departments have plans in place that if people need to be rescued, say if they're sick, they can't breathe, but they're still alive, they need to be rescued. And that's part of the whole crux of my paper, is that goes into detail on how fire departments don't need to wait for a hazmat team in gear like this to go in to rescue people if they're still alive. That you've got a certain amount of time and certain conditions that if they're met, you can wear normal firefighting gear to go in and rescue these people that are still alive. Why are hazmat teams needed? Well, for their training, experience, specialized equipment, and the resources that they can bring. Here's some examples of how hazmat teams can show up and begin to mitigate or clear up a situation with hazardous materials. If it's an oil leak on a waterway, teams have booms so they can release it into the water, and since oil floats on top, it should trap all the oil into here until they can get a rig to come suck off the oil that's floating on top of the water. And here's an example of level A, or the highest protection suits that a hazmat team member would have and they'd wear. And this is for like a gas. They have to go in and the area is completely enveloped in the gas. They would wear this. They have an air pack underneath, and there's no liquid, and there's no vapor getting in and touching their skin. It's the highest level of protection that a hazmat team member would wear. So here are a couple examples of hazardous materials team members at work. Down here, these guys are trying to fix a leak on the side of this. It's like a semi-trailer that's overturned. And the firefighters next to them are putting down what's called a foam blanket to help suppress any flammable vapors. Because the guys in the greenish yellow suits there, those suits don't provide any protection from flame at all, and if something were to ignite, they would be in a lot of trouble. The guys up here have identification tools, and these barrels are unmarked, so they're trying to figure out what's inside these barrels. And they're wearing the level A suit, which have the air packs and the face masks on underneath. And these guys down here are what's known as level B suits, so you can see their air packs and their face masks on the outside of their protective wear. And this is just a step down from the level A that we talked about above. And these guys have a machine here that breaks down whatever the product is that's placed on this little tiny high sensor here, and it tells you exactly what that product's made out of down to the chemical level. Some examples of the types of monitoring and special equipment that hazardous materials teams have. Up here is a radiation detector. Over here is a very common hazardous material monitor that many teams have and carry, and it detects a whole bunch of different things. It'll detect levels of carbon monoxide, hydrogen sulfide, which is a flammable sewer gas. It also reads oxygen levels. Another very important thing, which is known as the LEL, which is lower explosive limit, and it tells us how much of a flammable material is in the atmosphere. So if it's a high reading, then we know that we need to get out of there or change that environment, or wear something that's going to provide us protection from flames, such as our firefighter turnout gear. Down here, these are one of the types of antidotes that we have if somebody were to come in contact and get sick from different types of hazardous chemical. If we have these with us, we can administer these quickly to help negate the effects of whatever material they've contacted and is now harming them. And this setup here is the inside of one of our 2 hazardous materials response rigs. So if we're at work, we get a call, we leave our fire engine, we all hop in this thing and we drive to wherever the call's at, and we can immediately begin researching chemical properties and what suits we need to wear and what problems they can cause people. So we just hop in here, we have internet connections, loads of books, just get to work right away as we're driving to the scene. So what happens if you get some of the product or hazmat on you? So now I'm going to talk about decontamination, or decon as we call it. And this is how we get toxic chemicals off of us if we've come in contact with it. So there's 2 ways. Up here is what's called gross decon. It just involves a firefighter with a hand line, a water hose, spraying down the person that's come in contact with the chemical, whether it's a victim or a firefighter or a hazmat team member. He just sprays them down and gets as much of that stuff off as he can with the hose and water. If we have more time to mess around, and time isn't of the essence, we go to this, which is called a technical decon. And it can take a while to set up. You can see the intricate showers and the pools, and there'll be a couple of these stations set up. And so whoever's come in contact with the chemical will go through this line and have people scrub them at each step until they get fully clean. So how does this all relate to my capstone project? The idea is that if there's an emergency, like up here, where there's a toxic release and there's people trapped inside this building that need to be rescued, that we don't have time to wait for a full hazmat team response to suit up and to go on and make the rescue. And if people are alive inside this chemical environment, the first arriving firefighters wearing just this SCBA and turnouts can go in and make the rescue. So the 3:30 rule says that if somebody's alive, you've got 30 minutes wearing SCBA and turnouts to go ahead and rescue somebody, and 3 minutes just to search for people. So if you don't know they're in there, you don't know what the chemical is, you've got 3 minutes in SCBA and turnouts to look for people. Once you find them, you pull them out quickly and you go straight to the gross decon, where you're sprayed down, you and the victim are sprayed down with a hose line, and you go straight to the hospital. So my suggestions in the paper provide some points for a new toxic rescue protocol, the TDFNR, to help clear up some kind of ambiguous protocols that are currently in place. So in summary here, I've talked a lot about hazardous materials teams, what they do, what they're trained on, and how long it can take for them to get on scene sometimes. So they're all hazardous mitigation teams. So anytime something happens, the fire department's called, if the fire department can handle it, then they call a hazardous materials team. Typically can have long response times. Hazmat incidents can be accidental or intentional, such as the terrorist attacks. And turnouts and SCBA will provide some protection. That's the 3:30 rule. And then my goal is to empower fire officers with info to allow them to make a rescue. So that's pretty much it. I hope this cleared some things up and some terminology up, and you got a better understanding of how hazardous material teams work and what my goal is in the paper. Thanks for listening.